Hello guys, welcome back to my YouTube channel. My name is Mike Matthew KE and this is my Logic in Programming series. So today we're going to be looking at the bubble sort algorithm. We're going to be looking at how you can sort a list of numbers using the algorithm called bubble sort. So just dive right in, look at the theory behind it, and then later we're going to implement it in Python and in C++. So let's have a look. So the bubble sort algorithm works by swapping numbers based on which one is smaller. So if a number is smaller than the next one, then we swap it out. So you can see here, when we start out, anything that is highlighted in yellow means that's the section where we're looking at the moment. So the first time we have 1 and 6. We find that 1 is less than 6, so we don't do any swap. So we continue to the next iteration where we're looking at 6 and 5. We find that 6 is greater than 5, or rather 5 is less than 6, so we swap them out. So we have this is our next value here. We have 1 5. Then we look now at 6 and 3, where we have 3 is smaller than 6, so we swap them out. And then finally we'll be looking at 6 and 2, where 2 is less than 6, so we swap them out. At the end of it, this is what we get. But now you can see at the end of it, we still don't have a fully sorted array, which means we need another iteration, right? So we do this again. So we start from the beginning again. We have 1 and 5, where 1 is less than 5, so means we don't swap anything. We check next. We have 5 and 3, but 3 is less than 5, so we swap them out. Next, we have 5 and 2, where 2 is less than 5, we swap them out. And then we have 5 and 6, which 5 is less than 6, so there's no swap that happens. Then we end up with our result 1 3 2 5 and 6, which still we have it not fully sorted, so we need to go to another iteration again. So when we go to our next iteration, we start again from the beginning. We have 1 and 3, 1 is less than 3, so that is okay. Then we have 3 and 2, so we have to swap out since 2 is less than 3. And then we continue. We have 3 and 5. 3 is less than 5, which is okay. Then we have 5 and 6. 5 is less than 6, which is okay. And now we have a fully sorted list. So that's how we need to do our bubble sort algorithm. You can see that we need to keep swapping numbers out. And you can see that also we need to do more than one iteration. Once we try to sort once, it is not enough. We need to sort again and again. So if you think about it, we need 2 loops. One that will go checking whether we'll swap numbers or not, and the next one that will go through the several iterations that we had, right? So that we can have a fully sorted array. So let's look at this in code. We'll start out in C++ and then we'll do it in Python. So first of all, I'll be using a vector class here, so that we have our dynamic arrays in place. And then now we'll create a function. So our function, it will not be returning anything since we'll be taking it in by reference. So let's call it bubble sort. And then we expect it to take an std vector of integers by reference, and we call this our array, right? So here, first of all, we've been given an array of integers. So how do we start our loop? So our first loop, we expect it to run from according to the number, rather according to the size of our array. So we'll just use a for loop for int I equals 0, I less than the size of our array, I plus plus. Then that will be a first iteration. So according to our image here, this is the iterations that we had. So we had 1, then 2, then 3. This is our outer loop. Then next, now we'll do the inner loops. These ones that have the swap function taking place, right? So coming back here, we'll have the next loop, of which I'll use for int j equals 0, j less than array.size, j plus plus. Now here we have to be a bit careful when you're looking at this. The second loop, we have to look at how many iterations we need to do. So you can see whenever we're doing this, so here we have 5 elements, but the number of checks that we're doing are only 4. We're only doing 4 checks total, right? So here, when we are implementing this, we'll do array size -1. So next here we have to check between at the moment between this index and the next index, just like we had here. So this index, which will be index 0, and this index, which is by index 1, which one is the greater number? If the 0 is greater, then that means if our index 0 is greater, then that means we have to do a swap. If it is not, then nothing needs to change. So coming back here, we have to check if our value at j is greater than our value at j plus 1, right? And if it is, then we need to do our swap. So how do we do the swap? First of all, you need to store one variable away so that you can put the values. So I'll just demonstrate it like so. So our first integer, so let's call it big, so that we know we're looking at the big integer here. We have our big integer there, and then next we need to do now our swap. So we put the value of array at j is equals to the value of array at j plus 1, and then next now we need to modify j plus 1 to be the same value as our big integer right there. So now that's how you perform the full swap, right? So we have to store this big away first, because we are going to modify the value array at j. We're going to modify it so that it's this array at j plus 1, right? So at the end of it, we have that's now our value, and we expect that this at the end of it should be able to sort our array fully, right? Because remember, we are doing our loop so that we make sure we have done all the iterations. So iteration 1, iteration 2, iteration 3, like we had before. And then we have our second loop here, which will do now these individual steps where it's checking whether we need to swap it out, right? Now, since we're using the dynamic array size, that will allow us whatever array size we give, whether it's 100 or 10, it will always be able to sort them out. So let's try and see this in practice. So we'll create an std vector here of integers, and we'll give it let's give it a name to sort, right? And then we'll give the same as we had here: 1, 3, 2, 5, and 6. So 1, 3, 2, 5, and 6. So we're expecting that we have this sorted out. So we call our function. So our function is called bubblesort. So bubblesort to sort, where we pass our to sort array. Then now we can print out the values of this. So I less than array.size, I plus plus. Sorry, this is to sort, not array. And then we can see out the values of this array. So array at I. This is to sort again. So let's try to run this and see whether we'll have our sorted array. So you can see at the end of it, we have 1, 2, 3, 5, and 6 printed out correctly. So that's how you would implement it in code. So it's usually good to have this kind of a mapping in mind whenever you're looking at your code, so that you can see like this is how it's supposed to run. how you think about it, how you visualize it is the way that you're going to implement it. So let's look at the same scenario in Python, right? So in Python, we'll have the same thing. So we'll just have a function. We define a function called bubblesort that will take in an array, which is a list of integers, right? And then in this case, we're expecting it to return something. So we return a list of integers as well, right? So here we'll do, we'll start with our initial for loop again. So like we've done it before, so we have these iterations. So we had iteration 1, iteration 2, and iteration 3. So that's how we're going to implement it, our first for loop. So for I in a range of 0 and the size of our array, which is len r. And then again, we do another for loop here for j in range of 0 len of r minus 1. So first you might be wondering, why are we doing minus 1? So for the second for loop here is the one that we look at whether we need to swap out any values. And you can see, for example, in this case where we have 5 values, the number of times that we need to check the swaps, which one needs to be swapped, are only 4 in every time. Every iteration we're doing it only 4 times, which means we're doing it at the length of the array minus 1, right? And then next, now we check if we need to do a swap. So we check if the element at the index of 0, or rather the first element is greater than the second element. So in this case, we'll do if array at j is greater than array at j minus 1, then we do a swap. So how do we do the swap? We have a temporary element here, which I'll call big, because we've realized that j is bigger than j plus 1. This is plus, not minus. Then next we do, now we assign the value at array of j equals to array at j plus 1. And then now we give the value at j plus 1 the value that should be big now, right? So you can see we need to keep away this value at array at j, because we're going to reassign it in the next line. So we need to keep it away first so that we can be able to give it back correctly, right? So this should be able to sort our array. So we'll start with our array here, which is a list of integers, and we'll just specify as 1. Let me just look at what we had here: 1, 5, 3, 2, and 6. So 1, 5, 3, 2, and 6. And then after that, we call our bubble sort. Okay, so in this case, we also need to return, right? We need to return our array, so that we can say array equals bubble sort array. So we pass our array, and then whatever sorted array we get, we assign it to array, and then we can print array. So if I run this, we'll expect that we get our sorted array, which is 1, 2, 3, 5, and 6, right? So that's how you implement a bubble sort algorithm. It's usually good that you visualize your algorithm. You see how your code is supposed to work in your mind. That's how it usually works. Or if you're not able to conceptualize it in mind, it's usually good to see it the same way that we've done it with this PDF right here, where we have, this is the way we'll do the iteration, and this is the way we'll check our swap. That's one way of checking how you can be able to do your algorithms, and it is usually good to do it this way. You see, in programming, most of the programming is done in the mind, not on the actual code. It's actually done in the mind. The logic, how you think about it, that's all done in your mind. And then now programming, the section of programming is just coming to implement what you've thought about. So I really hope you have enjoyed this lesson. I hope you've learned how to do the bubble sort algorithm, and stay tuned for more.